This is Antonio Reid, Rising Tide, here with meteorologist Nick Humphrey. First things first, I just want to check to see if everybody can hear me. Am I audible? Am I audible? Just let me know in the chat. Hello, Karen, can you hear us? Uh-oh. Karen, can you hear me? Karen, if you can hear me, just let me know in the chat.
Hope everyone can hear me.
Okay. All right. There we go.
Okay.
People are responding. All right. Well, we're here with meteorologist Nick Humphrey. Today, we're going to talk about cloud dynamics, how clouds affect and moderate our temperature and our global climate and atmosphere. So recently, there was a paper that was published talking about the possibility of the disappearance of clouds and how that could lead to abrupt climate temperature rises around the world. So we're going to ask Nick Humphrey a little bit about, or a lot about actually in this interview, his opinion of exactly the understanding of these these dynamics and mechanisms that may cause a surge in global average temperature. So Nick, first of all, can you just discuss the generalities of the articles and about really cloud dynamics, and then tell us more specifically what this article is talking about?
Yeah. Basically, clouds regulate the climate by doing either two things. They either reflect sunlight, direct sunlight, shortwave radiation back to space if they're bright and reflective, or during periods of darkness, they actually will trap heat like a blanket in the lower levels of the atmosphere. So they tend to be very strong regulators of temperature on the surface of the planet. And the paper dealt with stratocumulus clouds, stratoform clouds, as they're called, or stratus type clouds, are clouds that occur in wide sheets across a surface. So very relatively flat clouds, very horizontal in nature and structure. Cumulus is more vertical in structure. So with stratocumulus, basically it's these shallow topped clouds that have sort of a lumpy appearance to them, but they're spread out over a wide area. So stratocumulus is the name for them, and they typically occur over. They're very common over oceans, especially over oceans with cooler water under them, usually along cold water currents, such as off the west coast of North and South America, California, Chile. And the reason that happens is because there's less upward vertical motion over cooler water. So you have colder air as a result near the surface, and then warmer air aloft. So the air rises, and then it tends to sink back down, and that motion is over a wide area. So you get cloud formation that's spread out over a wide area and sort of a lumpy appearance to the cloud. So stratocumulus structure. Now, the paper, with an understanding that 20% of the tropics have these stratocumulus type clouds, and they're heavy regulators of temperature and climate in the tropics and subtropics. And also the fact that global climate models, because of their horizontal resolution, they're unable to explicitly explicitly understand the cloud dynamics of these stratocumulus clouds, because they occur on spatial scales that are much smaller than the computer models are able to explicitly model. They created a model that is able to explicitly forecast, or not so much forecast, but so much um, describe numerically the flow and pattern of stratocumulus clouds, and then change the carbon dioxide level in the model to reflect the increase in heat that these clouds are exposed to, both in the air and in the ocean. So a rise in ocean temperature below, heat above, and seeing how do these clouds actually evolve over time.
So let me just ask, just for a point of clarification there. So the issue, I guess, that's coming up is that you're looking at a certain area where clouds would exist in the atmosphere.
Yeah.
And the models are not high resolution enough to really understand the individual dynamics of the cloud in that area.
Right.
Basically, what they have to do is develop an algorithm to tell us basically, on average, this is how cloud behavior will perform. Yeah. And then we subject that to different levels of testing CO2 to see how that will affect that, algorithmic behavior of the cloud. Okay.
Yeah, and just to be clear, like when I'm a meteorologist, so in forecasting world, we deal with weather forecasting models, and basically they have equations in them that take temperature, pressure, moisture, and then forecast it in the future at time steps. And obviously, the forecast worsens as you go farther out in time. Right now, it's about 7 to 10 days for any sort of reliably explicit forecast. And then they do probabilistic stuff beyond 10 days. With climate models are different. They don't deal with initial conditions. Weather forecast models forecast the future using the initial conditions and understanding of the environment, and then project those circulations into the future. Climate models take what's understood about the average, typical pattern of the circulation at a particular moment in time, and then evolve it into the future by changing what they call the boundary conditions, basically energy balance. So if say there was no anthropogenic climate change going on, the main driver of energy balance would largely be the changes in our orbital position with the sun, and changes in the sun's brightness over hundreds of thousands tens to hundreds of thousands of years. You could take a model to go hundreds to thousands of years in the future and track, how much the temperature of the Earth would change over time. And that's why a lot of scientists say if it wasn't for human global warming, we'd actually be cooling right now. That cooling would be a natural process of heat balance. So with global climate models, they change the CO2 emissions at certain rates and speeds to develop these scenarios for what will happen. Of course, the problem is that as you clarify these circuits, there are some circulators at small scales that the models can't explicitly understand the changes as you change the energy balance, that heat balance in the system. And it takes a lot of computational power to run these models. So you have to either care about going farther into the future to see how things change, or you have to care about what's happening at these small scales. Climate, modelers have chosen to care more about what goes on in the future for preparation and understanding how the climate may impact society. But the problem is that there's these things occurring on small scales that once they change dramatically, and they tend to be tipping points, then it changes everything globally and blows up your whole model scenario for the future. And that's what they found with basically the stratocumulus tipping point. When you get to about a level of 1,200 to 1,300 parts per million CO2 equivalent, so that's CO2, methane, nitrogen, water vapor, whatever else is in the atmosphere that's contributing to this increasing heat on the planet, your stratocumulus clouds that cover a wide area of the tropics and subtropics, they dissipate, and they dissipate fairly rapidly, allowing for rapid global warming, because now these clouds are very reflective. And
look, I want to slow you down just a little bit, because everyone is fully aware of the whole idea that we're at 410 parts per million CO2 in the atmosphere, and I think we're about 1750 or 1800 parts per billion of methane in the atmosphere. But the whole idea of CO2 emissions equivalency may be new on some of our viewers. So can you just briefly explain, first of all, what CO2 equivalency is, and then can you tell us where we are as far as CO2 equivalency in the atmosphere?
Yeah, so the reason they do, first of all, the reason they do equivalency for carbon dioxide is because carbon dioxide is the long-lived greenhouse gas. It stays in the atmosphere for hundreds to thousands of years before it's washed out through precipitation and locked away in soil or in carbonate structures in the ocean, or whatever else binds carbon. So that out of the way, the equivalency aspect of it is that there are some molecules that in certain wavelengths, infrared wavelengths, just like CO2, retain heat in the atmosphere. They absorb and then re-emit it back to the surface. The problem is there's some gases that are far more powerful molecule versus molecule to CO2 than carbon dioxide at doing that. And those gases include methane, nitrous oxide, both of which come from sources such as agriculture. Methane is increasingly coming from industrial sources that involve actually getting fossil fuels out of the ground, natural gas out of the ground. You get a lot of emissions of methane, and also certain chlorofluorocarbons and hydrocarbons that are emitted, some of which are supposed to be illegal, but there are signs that some countries are emitting those gases anyways in their industrial activity. And those gases, even if they're in very small concentrations compared to carbon dioxide, such, for example, methane, only about 1.8 parts per million in the atmosphere versus 410 parts per million for carbon dioxide. Methane is a very powerful greenhouse gas, so you end up getting over 100-year time scale, about 34 times the ability to retain heat into the atmosphere than carbon dioxide. So a small amount of methane goes a long way. And the thing with methane is its lifespan, its average lifespan is relatively short, only about, I've heard about 12 to 15 years in the atmosphere. But the concentration of methane is increasing in the atmosphere because of both industrial activity and there are increasing signs that more methane is pouring out of the Arctic permafrost, both subsea. The permafrost is very shallow offshore Russia and Siberia, as well as from the land. Now, as far as where we are, NOAA and also the Bureau of Meteorology, more recently updated theirs for Australia, indicate that we're near 500 parts per million CO2 equivalent in the atmosphere, assuming it were to not rise any further and decay over a 100-year time scale. That's what you calculate, about 500 ppm of CO2 equivalent. So 410 for just carbon dioxide, but it's 500 when you add in all the other greenhouse gases. So it's significant. And for reference, since we were a lot of times in the climate world concerned about CO2 doubling in the atmosphere, the doubling would be 560 ppm. And we started at around 280 for the Industrial Revolution. So, for the Earth, the Earth doesn't care whether it's in the form of CO2 or methane or something else. So, we're, knocking on the door of doubling the amount of CO2 equivalent in the atmosphere.
So based on CO2 equivalency, it makes these whole talks sound like a sham, doesn't it? Because based on CO2 equivalency, we are already at mid-century CO2 levels. If you looked at what the IPCC RCPs are talking about, so there's we were just getting an assessment from the International Energy Agency talking about the feasibility of staying in line with a 1.5 degrees Celsius temperature rise in a 450 parts per million scenario. All that has to be out of the window now.
Yeah, I mean, it is. I mean, long-term warming, just based on the fossil fuels and other greenhouse gases that have been emitted to the atmosphere by humans, we'll be exceeding in the longer term over decades, about 2.5 degrees. I've heard some estimates near 3 degrees. And that's before all the ice sheets melt away and everything else, just like.
And that's before this new dynamic, which clouds disappearing, and we're actually much closer to that threshold than we thought. I mean, according to the data you're sharing with us, we're almost 100 parts per million equivalency closer to 1,000 to 1,200 CO2 threshold to throw us into to get this feedback. And what type of temperature should we expect in the absence of this cloud layer?
Well, the actual feedback itself would be initiated around the time that the CO2 equivalency can cause a rise in temperature of about 4 degrees. And once that happens, you lose the stratocumulus cloud deck, and that causes the sensitivity of the planet to rising carbon emissions to increase dramatically, and that would mean a rise of about 8 degrees globally, 8 degrees Celsius globally. So you would have a rise of 8 degrees globally, represented in the tropics. The researchers discovered an 8-degree rise in the tropics, 10-degree rise in the subtropics, and globally it would be about 8 degrees across the entire planet. It's just all because the heat gets redistributed, so it gets very hot very quickly in the tropics, but that heat does get transported to the rest of the planet, and it's reflected in the planet's overall warming.
Well, let's break this down, because I don't want to give our viewers the impression that once you hit the 1,000 to 1,200 threshold for this, the clouds will just immediately disappear, or will they actually? Will it be an immediate effect? I mean, how long would it take to actually? Because we're going to cross this CO2 equivalency. I would say we probably have 20 to 30 years before we start really looking at a time where we're close to 1,000 parts per million equivalency in the atmosphere of CO2 emissions. And we're also talking about not just human emissions playing a larger role in this, but also permafrost emissions playing a larger role in this. So really, what time scale are we talking about before we have to really start worrying about? Because in a lot of ways, it sounds like to me what you're describing is a lot worse than even a 50 gigaton burp of methane from the Arctic. In a lot of ways, it sounds like something worse than
here's
that.
The thing: the feedback is something that occurs at a much higher temperature than we're at now.
Okay.
And the problem, but there's a caveat here. The caveat is that because humans have already done so much to the atmosphere in terms of changing the CO2 level of the atmosphere and other greenhouse gases, and exponentially over decades, many decades. And it's doing so at an end or during an interglacial period when there is huge stores of carbon in the soils, as you mentioned, in the permafrost. And the problem is that there's a lot already ready to go off that could get us that 700 or so ppm difference between where we are now and where we would need to be to initiate this further feedback. That would be absolutely crazy. And those things are already crazy in themselves. Obviously, we know about the potential for this. Most people cite the 50 gigaton burst, but it could start off, 1 gigaton, 5 gigatons. So there's already 5 gigatons of methane in the atmosphere as it is. So to even double that amount would start to accelerate global warming. And the thing that a lot of people don't understand is all of these feedbacks loops are not only looping in and of themselves, they're all connected to each other. So for say you get a 50 or 40, 50, 100 ton gigaton burst from the Arctic, it just catastrophically, the cleth rates fail and you start to get massive venting of methane. That warms the Arctic dramatically, causes the sea ice in the warm season to basically just collapse. It just fails. That causes further warming of the Arctic. It weakens the jet streams, causing more extreme heat and storms in the mid-latitudes, et cetera, et cetera. I've recently been aware of modeling of peatlands and permafrost in the Arctic, where there's a concern that as the rate of global warming starts to exceed, about 1/10 of a degree Celsius per decade, you would start to have a widespread decomposition of carbon in the soils, where the soil temperatures rise rapidly, and you get massive, melting of ice, and you end up having large stores of land carbon releasing methane into the atmosphere. So you're not even talking about subsea that everyone's concerned about. You're also talking about land permafrost. There's lots and lots of feedbacks. They're not only themselves, but they're also connected, and they lead to things happening faster and faster, even before you get to the cloud feedback.
Well, let me ask this question, because I think maybe some of our audience may be confused. I know I'm a little confused about this, but we all generally know that for about every degree Celsius, the temperature increases. We get 5 to 7% more moisture in the atmosphere. Wouldn't this hold true? And if it does, why then wouldn't the additional moisture in the atmosphere contribute to increased cloud cover?
Well, it would contribute to increase cloud cover, but more of that cloud cover would be increasingly convective, meaning you would get more upward building clouds that lead to more thunderstorms, heavier rain squalls, and less cloud cover that's in sheets and decks. See, the difference in how clouds form is based on what we refer to as the stability of the atmosphere. In an unstable environment, you have warm air near the surface, cooler air above that, and the warm air can rise or convect into the cooler layer of the atmosphere. That's how thunderstorms, heavy rain, squalls, those kind of events tend to form. With clouds that are flatter and spread out in decks, you tend to have either a stable environment or just shallow convection, where air either rises gradually over a wide area and produces these wide sheets, or you get convection that rises, but it's very shallow and is sort of capped, if you will, from going higher, and you get these lumpy clouds that spread out over wide areas. The convective clouds can be bright, they can reflect, but they don't do it over a huge wide area. these low cloud decks in the marine environment do that excellently because they're spread out. So you lose those clouds, then you lose a significant portion of your planet's albedo, the ability to reflect light and not contribute to additional heat being brought into the climate system. You lose those clouds, then you bring in a significant amount of heat.
Okay, well, I guess that explains that. I just wanted to clear up that one dynamic. Well, I think you did a pretty good summary on the article. Do you want to get into a Q&A session from the audience?
Sure. I think I would just add, like, as far as the speed is concerned, the speed is about basically as fast as the carbon emissions rise. And if you're getting significant warming of the planet already, where you're losing carbon sinks, your forests are burning that were there as carbon sinks, and you have more and more carbon being emitted to the atmosphere, then that's going to contribute to the warming the faster, because basically the loss of the clouds increases the sensitivity of the planet to rising concentration of carbon dioxide. And right now we have a fairly rapid rise compared to what it typically is during an interglacial period, much faster. But if you lose some of these climate regulating forces, such as sea ice, such as even ice from glaciers on land, and of course the stratocumulus clouds, all of these reflective properties are lost in the climate, and the climate will warm much, much faster. And based on the rising concentration of greenhouse gas in the atmosphere now, it would be over a period of just years that you would get that kind of warming.
Oh, wow.
Years, meaning, I mean, it wouldn't be it wouldn't be decades. It would be, very fast.
Well, let me ask you, so Willis Inns has a question. He says, have you ever considered what kind of difference the solution to pollution system would make? I guess I want to clarify that. So we all know there's global dimming. How would global dimming affect this whole cloud interaction? As you know, we're industrial civilization itself is creating an artificial cloud layer that's reducing the amount of solar radiation that's touching the surface. What happens if we lose this, and what effect would it have on atmospheric clouds?
Well, if you lose aerosols, and there's only two ways to do that: either a controlled reduction in aerosols that comes from, say, the horrible irony, you reduce, say, coal burning and other burning from industrial, fossil fuels, you actually reduce aerosols. A terrible predicament with that, even though coal burning is quite terrible on the environment. You reduce aerosols. Current estimates that I have heard have been in the range of about 1.5 to 1 degree of warming of the planet on top of what's already occurred. So it's kind of a one-time deal. There's already been some suggestion that the climate part of the global warming we are experiencing, or at least initially experienced coming out of the 1960s and 70s, was because of reductions in aerosols in the West. You still have significant aerosols being produced over Asia because those economies are growing, so they're burning a huge amount of coal. There's still some, but you can still find it throughout other parts of the world, obviously. But if you lose the aerosols, that increases, obviously, evaporation, because you're bringing in more sunlight, direct heating, and it would lead to higher moisture, but it's moisture that would come out in more extreme rain events produced by what we refer to as deep convection thunderstorms. that are capable of producing much heavier rainfall in the tropics and in the mid latitudes. And obviously, when you don't have heavier rainfall, in areas where there's less moisture, less clouds, and it just gets hotter. But that's the thing about I have to emphasize: the warmer your planet gets, the less of these cool clouds, these cool weather clouds, these clouds that are capable of keeping the planet cool. The less of those clouds that you have, and the more of these clouds that are more, say, subtropical, tropical in nature, that are capable of producing very heavy rainfalls. And so you get, damage both from heavier rainfall events, damage to infrastructure, threats to life, and also less opportunities to keep the planet cool, because you just don't have those type of clouds existing anymore. And obviously it becomes quite catastrophic once you actually lose those stratocumulus cloud decks at about 4 degrees or so above pre-industrial. So and losing the aerosols brings you closer to that.
Well, absolutely. So let me ask, let's make this political, since in the United States we're about to go through another dystopic nightmare of an election. It's really sad what's going on in the United States, but there's been an offer by the Democrats, a Green New Deal, based off of Dwight D. Eisenhower's New Deal, but this one is geared toward responding to abrupt climate change. It was authored by Alexandria Ocasio-Cortez, the Democrat who took down Joe Colley. So let me ask you, what are your thoughts about the Green New Deal, and does it go far enough to actually provide us the solutions we need to respond to these abrupt climatic changes?
I'm not really sure what to think about the Green New Deal. To me, just thinking about it from a scientific perspective, the only way you can challenge climate change, and really it's abrupt climate change. It's happening very, very rapidly. The only way you can deal with it is to actually physically remove the pollution, the pollutant that is actually heating the planet, and that's carbon dioxide. And to me, while the technology technically exists to do that, to have it exist at the scales needed to remove hundreds of gigatons, hundreds of billions of tons of carbon dioxide from the atmosphere is in my view, it's just very infeasible. So to create a deal of some kind, or programs to try to build more things to get off of fossil fuels. I mean, it would be great to be able to get off fossil fuels, but at the same time, you have to be able to deal with the elephant in the room, because if you're going to build more stuff, whatever that stuff is, it could be more solar panels, more wind energy. Some people want to do nuclear energy. That's a lot of concrete. That's a lot of everything. It takes a lot of mining, a lot of energy and a lot of pollution you make in the process to build more stuff to get to where you want to be. And that's more, tens to hundreds of gigatons of carbon that you're going to have to burn. It's kind of the sad predicament of the situation. You need business as usual to save you from business as usual. And nobody's been able to solve that equation yet, because there's no such thing as a free lunch, no such thing as free energy. So,
well, ideally, if we weren't suicidal as a species, and I come to this by a background of mass violence and societal collapse. Okay.
Yeah.
And when the United States decided to elect Ronald Reagan, that was another iteration of the Trump phenomenon. That was an earlier iteration of the Trump phenomenon. You got to remember that Ronald Reagan came into the White House, and his demonstration to the American people on this issue was ripping solar panels off of the White House as a show of force that science was not going to dictate policy in the United States.
Yeah.
And when he made that decision, that was a decision to squalor the carbon budget that we had. It may have been possible at some time, I think, that we could have enacted a Green New Deal, and like you said, it would absorb a lot of the carbon budget, but maybe we would have had enough carbon budget to actually make the transfer. But now we're 40 years into this, and emissions are 65% higher than they were in 1990. And also, I was just recently looking at a graph where it shows that about 50% of our emissions have occurred since 1989.
Yeah, basically since a little after I was born. Yeah, I mean my whole life has basically been the lead up to this this calamity. I mean, it is.
That's kind of the way. I guess I think what you were born in 87.
84.
84. Okay, I was born in 93, so that's kind of the way that I look at it. Is right around 3 years before my birthday. This is kind of all set in stone. You know, Dr. James Hansen came to the Congress in '89. The United Nations Environment Program, the IPCC, released their first report in 1990. And you know what the United Nations Environment Program said in 1990, warning us that we had a 10-year window of opportunity to get this under control before we lost the human ability to deliver this. In 2000, we failed to. 2000 was the same thing, right? So basically, we had the prototype of Obama. We had Clinton, and he was working on the global consensus on climate change, the Kyoto protocols, the equivalent to the Paris Accords. And he refused to actually make them legally binding and kind of left it up to the next president to come in. And who was the next president? It was a shock. It was a scare. We were surprised. It was another maniac Republican, George W. Bush. His theory was we don't have to do anything on climate change. The theories, the jury's still out. And then in 2016, this happens again. Everyone's shocked. We're surprised. And then another climate denier comes out after Obama's unable to make these accords legally binding. And so we squandered our time. And now people are starting literally to feel the heat and the pressure. And it's starting to happen. One thing I want to talk about before we conclude here is, have you heard of the 2007 Age of Consequences that was put forth by the International Strategic Studies think tank by the Pentagon?
I've heard a little bit of it. I haven't read it or had much detail of it.
They outline 3 scenarios for the 21st century on climate change. Their expected scenario, severe scenario, and catastrophic. Their expected scenario was 1.3 degrees Celsius global average temperature rise by 2040 of the 1990 level.
Yeah.
So the Pentagon was, and this was expected. John Podesta, if you remember who John Podesta is, he's the former advisor to the Clinton White House. He's the former transition chief for the Obama White House, and he's the former campaign manager for the Hillary Rodham Clinton campaign 2016. He's leading this study in 2007, and the Pentagon at the time is predicting that we're going to get 2 degrees C. We should expect 2 degrees C by 2040. Their severe scenario, which incorporated feedbacks or began trying to qualify and quantify feedbacks, had us at 2 degrees of the 1990 level, which puts us almost at
3, approaching 3, like 2.
Yeah, 2.7-ish. Yeah.
Yeah.
So this is getting serious. You know, this is crunch time. The IPCC is obviously the public numbers. The IPCC numbers are obviously conservative. It seems like we're finding out every few months now that there's some new feedback occurring, or that sea level rise projections are higher than predicted, or methane projections or numbers are going up, or CO2. There was the hope in 2016 and 2017 that CO2 emissions were stalling or going flat, and then reverse. 2018, they're higher than ever.
Yeah. Yeah. I mean, it's quite dire. There's really no other way to put it. I mean, the as long as the world keeps growing and has more need for or want, not always a need, sometimes it's a gluttonous want for energy, the easiest energy source is going to be used the fastest, and that's right now fossil fuels. I mean, you may not be able to get some, others may become more difficult. There's some signs this idea of peak fossil fuels or peak oil may be reached right about now, actually in the late 2010s. But you know, is that going to stop people from using the energy to burn more and more and more and make more stuff? And then you have people in other parts of the world that legitimately have not had an opportunity to have a higher standard of living. You know, their countries, their governments are trying to build more, you know, coal power plants to get them going. I mean, it's bad, and really it's not only what's happening now, but what has already been done that continues to haunt us. You know, that's why, you know, when people attack, say, China or India, well, I mean, yeah, they're doing a lot to hurt the environment, but you know, what Europe did and what the United States has done, that legacy is still it's roasting Australia right now. It's basking Europe in ridiculously warm wintertime temperatures. It's destroying the jet stream and causing this ridiculous great freeze in the middle of the United States, one of the coldest or most anomalously cold parts of the world right now is the central U.S. and central Canada.
Well, let me also say this:
that legacy exists.
So, like we say, that half of emissions have occurred since basically 1990. Well, by 2030, you know, we're talking about by 2030 we will just begin, because there's about, from my understanding, correct me if I'm wrong, but there's a 30-year inertia due to lag effect due to thermal inertia. So we won't really we'll just begin to feel the emissions from the 1990s by the 2020s. So we'll just beginning to feel the emissions, half of which we've done just in the last 25 years, just starting now. And we're still set to continue to burn of course, we're not going to peak, because China said they're not going to peak for at least till 2030.
Yeah. So that's right. I mean, we're going to start experiencing the effects of the massive growth in emissions that occurred since I was born, basically since you were born. And we're doing so, finding out about all of these feedbacks that we didn't know about 30 years ago or even 10 years ago. You know, the thing about the feedbacks is a lot of them have only started to really pick up steam in just the last 10 or 15 years, like the rapid deceleration and the strength of the AMOC, the Atlantic Meridional Circulation in the ocean, that regulates temperature and heat in the ocean. That's a lot of that weakening has occurred in the past. It's thought to have occurred in the past like 15, 20 years. jet stream becoming wavier, same thing, about 15 or 20 years. The Arctic, the rapid acceleration and the decrease of sea ice, especially volume, past decade and a half. The so-called Clathrate gun to release more and more methane. It's beginning to release more and more methane from the eastern Siberian shelf. That was, really started to pick up about 10 years ago. I mean, it's all of these things that we're even if we didn't explicitly know about them, there were things that we're worried about when the climate scientists were talking about 1 degree being this cutoff that we don't want to really be exceeding back in the early 90s. They didn't necessarily know all of the abrupt feedbacks that could take over. They were unknown in many cases, but they knew that when you start changing the known aspects of the system enough, things that go unseen start to accelerate and begin to become seen, and by then you can't do anything about them.
I think there's a tipping point for human civilization as well. As I'm looking at this, look at what's happening across Europe. Okay, this is very reminiscent to the lead up to the Second World War. This is, we're starting to see fascist countries really dominate the political sphere. We see it in the United States. We see it in South America with Bolsonaro. We see it in Spain. We see it in Italy. We see it in Germany. We see it in Greece. We see it in Mesopotamia. We see it in Serbia. The crisis, the great crisis, the great refugee crisis has already begun. Okay.
Yeah.
And what's central to every right-wing politic that's coming up is the immigration crisis. All of the far right in Britain, they're talking about it, in French, they're talking about it, and they're talking about it across the world. And all the right-wing politics is the immigration crisis. And it is because we are undergoing the great immigration crisis.
Yeah.
Change. That third world countries, like you say, the equatorial regions are warming up, quickly becoming inhospitable to human life. The crops that are grown, the staple crops that are grown in the equatorial regions, they don't have a lot of climate sensibility. So climate goes up a little bit for them, it's over. We're starting to see more desertification of fertile lands. We are seeing a widespread destabilization of the human population, and the equatorial regions are beginning to empty out.
Yeah, I mean, from a political standpoint, climate change is a disaster, and the faster it goes, the more abrupt it is, the more abrupt a disaster it is in economic and political terms. And to me, the rise in far right politics is, I think, a reflection of the decrease in the resources of the planet, and really the fear of those perhaps more affluent to not want to provide for those that are less need the help the most. And people tend to run toward those people that tell them we have to protect our own, we have to protect our stuff, our rights, our power, regardless of how much power those people may actually have. And I'm talking about those that support those rulers. My biggest concern is that there's going to be a tipping point in the countries that are in the tropics where it's going to get simply too hot, too dry, too arid in the Caribbean and parts of South America. And you're going to abruptly have, abruptly meaning over the course of, years to a few decades, have a huge number of people starting to just flood out, because it's too difficult to live down in those areas anymore. And at the same time, you're going to start having increasingly more damaging impacts from abrupt climate change in the affluent countries. The United States, the Great Plains, it's going even at 1.5 degrees it's going to get bad for crops here in this region. By 2 degrees, it's going to get really, really bad.
You're telling me right now,
you're going to have people trying to, or you're going to have this country trying to deal with feeding its population as the crops fail here in the U.S., and then have a ton of people coming up north trying to escape air warfare, famines.
But this is literally unfolding as we speak, though. That's the point that I'm trying to make to people. I'm outside in North Carolina right now, and our dogwood trees are blooming in February. Yeah. Our seasons, the entire biosphere around here is surreal to me. I mean, I am not growing up. I am not living in the place that I grew up in my own hometown. We are seeing the crops. It's taking a toll. The flowers are all bloomed and they're out, and it's set to be in the low 20s Monday, Tuesday, and Wednesday this week. I mean, this is truly phenomenal what we're seeing. And you're right. We're going to start seeing not only an external refugee crisis in the United States, where people are coming up from Latin America, the Rio Grande, but we're also going to see internal refugee crises. I mean, we're talking about a situation where coastlines are going to begin to flood. We're going to experience storms that are the size of states stalling for days, dropping feet of rain. I mean, this is getting to the point where the whole talk about geoengineering the atmosphere, at one point it was totally off the table, and they would only say that wackadoos are talking about this. But you got real scientists putting their names on this now. People who are at decorated universities, high-level PhDs. You have Harvard out in the desert, Arizona, already testing regional SRM. So this is really happening. This is full scale. This is going on.
Yeah, I mean the past probably 2 years, especially. I mean, beyond the realization, I think for a lot of people has been in the past couple of years, because 2016, 15, 16, it was a nasty El Nino, but you could excuse the extremes. But the extremes keep getting worse. You're going beyond El Nino. We're in a new El Nino now, and for me, it's almost irrelevant, because you've seen the extremes worsen in 2017, 2018. These mega floods, every day, every couple days or every couple times a week, I'm hearing about some new ridiculous, insane flood happening somewhere. I've never seen anything like this, and the heat. The last year's heat in the Northern Hemisphere, and then the heat that occurred before that in the Southern Hemisphere. Now it's even worse this year in the Southern Hemisphere in Australia. It's a realization that we're kind of reached a point where that you cannot ignore what's happening any longer. And for me, living here in the middle of the country, we had the heat, but we've also had the extreme swings between heat and cold. Like last year, we had here in Lincoln one of the coldest Aprils on record, and then we swung almost violently, if you will, to one of the hottest Mays on record, and it was the hottest May for the United States as a whole. It was just absolutely going from the icebox to the roaster in 30 days, less than 30 days.
But it's also not, and what's also interesting to me is it's not always the headline grabbing weather phenomena that signify climate change as well. I mean, it's also for us. So for example, we've been experiencing days in the upper to mid 60s and even the low 70s. Well, that's 10 to 15, 20 degrees warmer than it ought to be, but it's just a nice, really comfortable day. The sun's out. No one's really but that's also part of the weather derangement as well. That's just as indicative of this weather weirding, freakish event. Even though it's a nice, beautiful day, it's a nice, beautiful summer day in the middle of February.
Yeah.
So people
I mean, that's the thing with climate change. It causes not only lots of like new records or whatever, but it causes changes in your in the amount of days or events that you're getting that are not necessarily record breaking in and of themselves, but they're just abnormal. They don't occur, you know, in a normal climate, you might get those days once in a while, once in a blue moon, so to speak. But now you get them constantly. And then in a case, like I said, here in the plains, we're starting to get more situations where we're swinging wildly. Like today, the high was like 8 degrees, and that was at midnight. It actually got colder as we got through the day, and so it was like 4 or 5 degrees here in the afternoon. The normal temperature is like 45, 47 degrees here. We've had just days and days of being like below freezing. We're going to be below freezing for days, even as the normals are approaching 50 degrees this time of year. And then, you know, my biggest concern is if this lasts too long into the beginning of the crop season, you know, they can't start planting their crops, and then it may suddenly get hot. And that's not good for the plants either. And, you know, last year, and the strange thing is that in December, it was actually, we had a lot of abnormally warm days. So we didn't actually have soil freezing, like normal soil below normal or below 32 degrees freezing of the soil like we normally do later in December, because it was abnormally warm in December. And it's only in after early January, it suddenly got cold, and it's been very cold the rest of the winter. So it's very it's been a very like strangeness that, you know, is going on. You see it in the data, but it's another thing to actually just see it, the strangeness of how everything's functioning.
No, it's absolutely, to me, it's kind of like living in a twilight zone, because you never, you know, when I was growing up, you never really thought about the weather as being something in of itself can be deranged. You know, you just always accepted it as this kind of background context, and even despite the fact that weather varies every day, you understood, your sense of the nature of weather was you understood how the weather was supposed to occur. And now we live in this time where there are days in the winter where if I didn't know any better, I would think it was the spring or the fall or the summer. I can hear birds chirping. I don't know their names, but I've always in my life, I remember hearing these same type of chirpings at different times of the season, and now I'm hearing them where I'm not supposed to be hearing them.
I mean, I remember last year was the strangest year I've ever had on the plains, because I had to literally look at the weather forecast every single day. Otherwise, I wouldn't know what clothes to put on. You know, they joke around here. They joke around here like, oh, you know, wait 5 minutes, you get new. You don't literally wait 5 minutes. Like I would actually like not know if there is another in March, or if there's another Arctic front coming to blast us with ridiculous cold for that time of year. Like I remember one day we hit 82 degrees, and then 24 hours later, I'm driving on the interstate west of Lincoln, Nebraska on I-80, and it's snow starting to fall. It's 32 24 hours later in the afternoon. The day before, I was walking in a park with my fiance, with people walking their dogs and fishing, and it's 82 degrees. It's like, what? A record high, and then 24 hours later, we're getting snow.
And people are acting like this is normal. I mean, like literally, we in North Carolina, it's incredible. December, we experienced a historic snowstorm that dropped 12 inches of snow.
I remember.
In 24 hours. Absolutely historic for this area. And then on New Year's, it's 75 degrees. And people were just out in their shorts and washing their car. That's how they took that. And it's really. For me, this is the part of climate change, and I told all my friends this was the part of climate change that was going to cause the most psychological impact on me. And that is being able to understand a very highly sophisticated way of what's happening, feel that emotionally, and then see it happening, and then see this type of extreme disconnection from everybody else and what's actually happening out in nature. There's such a dissonance between the people of our civilization and nature that it's actually, in a lot of ways, it's horrifying. I mean, people are so out of touch with our Mother Earth that they don't see these things as being clear indications and signs that things are out of whack. I mean, people are still having babies. I would have at this point, looking outside over the last 5 years, particularly, I just couldn't. Right now, I'm so sure, just trying to extrapolate in my mind what I'm seeing outside on the daily. If I extrapolate that over 20 years, I know this is going to be out of fucking control. My fridge, but
yeah. I mean, if you just look at like everything that's happening, take even a linear. Don't assume it's going to accelerate. Just a linear trend in the sea ice volume since 1979. In the summer, in September, it's going to be no sea ice in the September by the late 2020s or early 2030s.
Even Michael Mann's coming out and saying that. Michael Mann's just come out and said, "Oh," and he says it so calmly. "Oh, well, some of the models, said that it's going to be 2100, but now we think 2030." It's like, that's catastrophically different.
Yeah. Yeah. I mean, you lose. I mean, that's for zero sea ice volume. Like, it may become pretty much at any time, there may become a tipping point where you just lose enough volume, then the Arctic abruptly warms. It may already.
It doesn't come.
It could be happening right now, and we don't even know it, and we won't realize it until it gets dramatically worse that it happened, that it already started. Because the Arctic is getting, even right now, the Arctic is extremely anomalously warm right now, like 25 degree Fahrenheit temperatures in the interior Arctic right now. I mean, that's not supposed to be that warm. It's supposed to be like 25 below.
And we know what's happening in the Arctic. In your cloud paper, it was talking about alligators swimming in the Arctic, that monkeys were up in the Arctic swinging through the trees. That's what's happening. I mean, the Arctic is racing back to this pre-mortal time.
Yeah.
And we're watching this. We're literally going to witness the atmosphere. I think Paul Beckwith said it. By 2030, we would have moved the atmosphere equivalently back 3 million years.
Yeah.
That's the dawn that's before our species. We're only 250,000 years old as a species.
Yeah. And I mean, even before, like, the primitive humans, Australopithecus, I think, roamed the earth like 2 to 3 million years ago. I mean, it's just like there's nothing really like us that has seen the world look like that. And when they were highly restricted in habitat, compared to now, where we roam every part of the planet. When you look at it from that perspective, like, how far back are we turning back the clock? You realize that it's how fast it is compared to what nature does, and typically does.
3 million years in 10 years.
Yeah.
I mean, we're already basically at 100 or 800,000, but that's 2.4 million years and 10 years of atmospheric history, and we're not stopping there.
Yeah,
we're even going faster.
Yeah,
it's just truly incredible to think that we're living in a time where all this is not a movie. This is actually real. We're literally sitting on our planet under the sky, and all of this is happening in real time. And this will be the story of our life. This is the story of our life right now, as you say. We were there at the beginning, and we'll be there.
Yeah, and that's why, as a meteorologist, the thing that people connect to the most is weather. And a lot of scientists, especially fellow meteorologists, spend a lot of time trying to make sure people don't get confused between climate and weather and the differences between the two. But and obviously that matters, but climate change is happening at fast enough speeds that a normal person that's not asleep at the wheel and going out to wash their car in February, 75-degree weather when it's supposed to be like 50, they're more than capable of realizing that climate change is happening abruptly enough that you can see it in both in data and in the human experience on meteorological timescales of weeks, days to weeks. You see these wild swings in temperature, these anomalously warm temperatures that just don't seem to have an end in sight. These ridiculous heavy rainfall events that used to occur just once in a while, they occur all the time. Australia. I mean, my God, Australia is just literally like a hot. It's been thrown on a hot plate. I mean, it's just hot, roasting, ridiculous heat. And if they're not getting that, they're getting the heavy rainfall events that produce these mega floods. I mean, like how many mega floods can you have in like a year in on this planet? Like it's normal now to have these mega floods. It's just like normal, like you have Harvey, you have, what happened in North Carolina, you have, what's going on in Australia. Like, it's just normal now. When did it become normal to have these mega floods? I don't. Yeah.
They're preparing. I was watching a video on YouTube just the other day, and they're showing the coastal authorities in New Jersey, the abandonment of the coast is gone. It started quietly here and there, but they're starting to use eminent domain to buy, houses that are under the national and flood insurance are under repeat. They cross the surge statistical analysis because they get hit by storms too often. It's just getting worse as it rises. So they've already started purchasing property, but we're going to see our total housing market crash. And I mean, this is something that we're talking about 10, 15, 20 years at max away, because for every 1 foot vertical sea level rise, you get 100 feet of inland inundation. So we're really just at the crux here. I honestly don't like saying these things, but I think it's true, and our viewers need to consider this. But we're really living the last 10 to 15 years of normalcy. And it won't even be that normalcy. It will really be a derangement of normalcy. But we are clearly in the last decade of living like, the last decade or so of living like this. The physics are just coming in too hard on us. And I God bless AOC and Bernie Sanders, and we obviously need to go ahead and do all that we can, a Green New Deal and much, much more, because we are in the fight for our lives is commencing, ladies and gentlemen. A lot of us won't realize it until it's too late. I know the United States military is on top of this. Militaries all over the world are on top of this. The Chinese are looking at, look at their problem. They're building up so much on their look at Shanghai. Shanghai is going to be gone. And we're talking about hundreds of billions of dollars of infrastructure. And we're talking about 300 million Chinese who will have to abandon the own Chinese coast.
Yeah. It's basically the last years that maybe most of us get to live like kings compared to a lot of people around the world, perhaps, and for a lot of people around the world that are already having trouble with food, water. It just gets much, much worse for them, and it starts getting worse for us. Nobody's safe.
Yeah. Well, I want to thank you, Nick Humphrey, for this conversation.
Yeah.
I absolutely enjoyed it. Very informative. And of course, our viewers loved it. We have over 195 questions, and we had over 20 viewers this time around. Very good questions and comments. So we will continue to give it to you like we see it, ladies and gentlemen. I'm sorry this particular one seemed grim. But we believe that delivering the truth in an honest fashion is the best that we can do. We are here together. We love each other, and we are in these moments to the end.
Yeah, absolutely. And thank you for having me.
Absolutely. All right. Good night. Thank you for joining Antonio Reid at the Rising Tide, sponsored by the Environmental Coffee House.